All right, good morning. Hi, everyone, or good afternoon, no matter where you are. My name is Jen Waltz, and I am responsible for partner alliances here at Improving. Our guest speaker today is Alan Moore. Alan is a principal consultant. He's been with Improving for quite some time, and today he's going to speak on these are not the tests you are looking for. I'd like to ask everyone to, if you could, during Alan's presentation, you could post your questions in the Q&A text area, but we'd like to have everyone wait until Alan's presentation has ended, and then he will address the questions as they came in. So with that, I'd like to turn it over to Alan Moore. Alan, the floor is yours.
Thank you, Jen. So I want to thank everyone up front for taking time out of their busy schedules to join us today. I know you have a lot of choices when it comes to learning opportunities, and so I really appreciate your participation in our Lunch and Learn series. I'll do my best to kind of make it worth your while, but if you don't find it valuable, then I'll be offering a full money back guarantee on this free event. My goal today is to share a strategy and a way of thinking about how to approach test automation for your enterprise. And I'll offer some tips and tricks along the way that can help you be successful. 10 years ago, maybe even 5 years ago, this talk would have needed to be a very different talk. The assumption in my title is that you're at least attempting to include automation as part of your standard development process. And in the past, I would have normally spent probably the 20 minutes of the presentation just convincing you that you needed automation as part of your practice. I would talk about the benefits of automation, how it can speed up your regression cycle, how it can ensure higher quality in your software. But in today's world, everyone pretty much understands you have to be doing test automation. There are, of course, some detractors, but in my experience, these are people who have tried automation in some form at some point and have failed to realize the benefits I just mentioned. In fact, they may have experienced the opposite, like a slowdown in delivery and a decrease in quality. But by and large, the industry leaders have beat the automation drum long and loud enough that most people acknowledge it needs to be done if you want to stay competitive. And in the last few years, we've seen the emergence of the DevOps model, which absolutely demands that we find a way to incorporate test automation in our process. In fact, you can't really say you're doing DevOps if you don't have a relentless focus on automation for all aspects of not just testing, but your development, provisioning, and deployment processes as well. And yet, a lot of teams are struggling to figure out how to do test automation effectively. And when I get into a new situation where I'm asked to help them understand why they're failing, there's always some common themes that arise when I start to engage the team about the struggles they're having. And the story often goes something like this. Someone says, hey, we need to get started. We need automation. So what do we need to do to get started? Well, we need a tool. You can't do automated testing without a tool, right? Cool. Who knows something about automated tools? No one? Well, okay. Since testing's a QA thing, you, QA tester person, go find a tool you like and let's get to it. So this extremely talented and gifted quality analyst who may or may not have any exposure to test automation tools goes to Google and does what we all do. Best test automation tools 2020. And you get a result something like this. "20 best automation tools, top 10 automation tools, 20 best automation tools." It's kind of like asking a recent college graduate in computer science to pick a development tool for the team. You won't get any less clarity from Google by searching best development tools 2020. But she knows there's a better way. Is everybody seeing my screen?
I can't see your screen, Alan.
Yeah, I just realized that I wasn't actually sharing. How's that? Okay. You didn't miss much. This is actually the first slide other than my intro slide. Apologize for that. So she goes and searches for Google, on Google for some testing tool. She finds this huge array of options available. But she doesn't really know a better way, so she pushes on and she digs and digs and she starts seeing Selenium everywhere. So she's like, well, okay, this seems to be popular, let's try Selenium. So this poor soul goes to the Selenium website, starts reading, and it slowly dawns on her that there are, I don't know, a dozen flavors of Selenium. And just the configuration and setup page starts to give her a headache, even if she knew kind of what language binding she wanted to use. So before long, this poor person is like, man, there has to be an easier way to do this. She goes back to Google because she remembers seeing something about record and playback, and that sounds pretty good. So she eventually finds a tool that supports record and playback and has a pretty good interface, seems pretty straightforward to use. She's able to write a few tests against the team's own application. She's like, cool, this will work. She takes it back to the team and shows them what she's done, and they're all amazed when they see the application running itself under the test tool. And everyone's pretty excited. So fast forward about 6 weeks. Teams now has about 15 actual automated tests, and they're struggling to find time to write more automation because they still have to keep up with the manual testing required to stay on top of new features. And they're struggling even with the few tests they do have because every time the team pushes a change into the QA environment, half the tests fail. And it takes all of the allotted automation time just to figure out how to fix the tests. So this kind of leads me to my first point, which is if you start with tools when you're trying to implement automation, you're starting in the wrong place. And I often get asked, what tool do I recommend? And my response is, I don't really care what tool you use. The tool does not make or break an automation program. Now, don't get me wrong, there are some tools that are better than others. And I have my favorites and I have the tools that I love to hate. But it's not the most important question you need to answer. And it's certainly not the first question that you need to answer. So people ask me about tools, and I say, look, I don't really care about the tool. And I'm kind of met with blank stares, and they're like, so what do you care about if you don't care about the tool? And my response is that I care about the overall automation strategy. What is your quality process and what is your culture? Before you jump in with both feet in an automation program, have you really thought about what your automation strategy should be? So if you've done any research on test automation and the different kinds of tests you can and should be writing, you've surely come across this image. This came out of a conversation between Mike Cohen and Lisa Crispin back in 2003. And it was first formally described in Mike's book in 2009 called Succeeding with Agile. So in this book, he referred to it as the test automation pyramid, but in use, it's generally just referred to as the test pyramid. And this model is really pretty effective at distilling down the essence of what a test automation enterprise should ideally look like. But its simplicity is also, in my opinion, its weakness, because it hides a sizable degree of complexity and nuance. In fact, I can probably guess that as you're looking at this, you're thinking to yourself, hey, I know what a unit test is, although I'm going to probably challenge what you think you might know a unit test is. And I know what a UI test is, But what is this middle layer really? What are service tests? And if you look around the interwebs, you can find dozens of variations of this pyramid that might have terms like integration or component or API. Here's one that calls it business rules, functional testing. Here's one that it says acceptance tests, integration, API testing, a lot of different terms that you find in that middle layer. But it's kind of a fuzzy and nebulous thing, and it takes a lot of hard thinking to really discern what is meant by service tests. And this model also primarily communicates that just as a triangle has more area in the lower part than its upper part, so you should make more automated tests on the lower levels rather than the higher levels. And that's true, but it doesn't really suggest how these tests relate to the real world problems that we're trying to solve with technology. So for this reason, I'm often referring to a different model now when I try to talk about this concept. So James Bach came up with what he calls the round earth heuristic of test strategy. And the first thing you'll notice is that this image itself has more complexity than the traditional pyramid models. So it requires you to engage a little bit more carefully and think about what you're seeing. And he argues that this model preserves what's useful about the pyramid, but minimizes its drawbacks. So notice this model represents the layers as concentric circles, because the outer surface of a complex system generally has more area to worry about. By representing technology as concentric spheres, we're highlighting the fact that the volume of possibilities, that state space of the product that you have to be concerned about, tends to increase dramatically with each layer. And the upside down pyramid shape is also intentional because it suggests that our attention and concern is ultimately with the surface of the product. This is where people live with our software. In the test pyramid model, that UI layer is really small to represent the number of tests that the system should have at that layer, but it might falsely suggest that the behavior of the system as experienced by the user doesn't deserve as much attention, and that's really tacitly false. So the round earth strategy also incorporates dynamic elements as well as static elements in the analogy. So you have things like data and user input. It's not just about code. As we'll see in a bit, test data and the ability to quickly and cleanly manage it is a fundamental building block to a successful automation enterprise. But in most places that I've been engaged, test data isn't really thought about in the sphere of automation until it becomes a recurring source of fundamental failures. This model also acknowledges that we can't or we won't really directly test the lower levels of our technology. Our operating system, Windows or Linux, Chrome or Node or Android, those .NET libraries that we rely so heavily on. And in fact, we're often encouraged just to kind of trust these things since there's little we can do about them. But there are security implications in all of this, and it needs to be considered. It also highlights the fact that these things are necessary and required. And it leads us to take note that a test environment must be thought about. Where are we going to run these tests? Do we have a dedicated environment for automation? And how production-like is it? Ideally, we want our test environments to be configured exactly like our production environments, so that when we validate our product, we are doing so on that same bedrock that it will run on in production. And if we're sharing this environment with other people, what impact will their use of the system have on our automation and vice versa? So as we move up to the next layer, where we start getting into the code that we are responsible for, that we write ourselves, this is where we talk about unit testing. And I need to find my place in my notes. So unit testing is where we're focused on testing small bits of code in isolation. And this is really a developer activity. And unit testing in TDD really should be a fundamental tool in your development toolbox and in your automation strategy as a whole. Stepping up from that layer, we have this nebulous middle ground where we're trying to find strategies for testing interacting subsystems and services. And I like this label better than just service tests because it hints at the complexity and the multiplicity of technology at this layer. And again, this is a domain where developers need to have a critical part. The tools and methodologies at this level are often require quite a bit of programming and architecture skill. It's also time to start introducing data, production-like data, both in terms of quality and quantity. And then finally, we have at the top the UI layer where the user's perspective and variability of user input has to be taken into account. So on the right of this model, it kind of draws out some of the principles that are familiar to the triangle. You know, quality above on the surface requires quality below in the foundations. And it's less expensive to write tests at the lower layers. So we spend a lot of time writing a lot of tests, providing a large amount of coverage at these lower layers. And that in turn reduces the dependence on expensive high-level testing. And I like this model better than the triangle because it forces us to think more critically about how we invest in our testing enterprise. And it also reminds us of the importance of testability. You know, one of the findings of the 2015 State of DevOps report was that one of the top predictors of team performance was whether the application was architected or could be re-architected for testability and deployability. And so because of this, I usually push teams, I used to really push teams to start with unit testing first, especially test-driven development, because I believe that a test-first approach at the unit layer will drive testability. It will force you to start writing your code in a way that can be easily tested. And unit testing, is cheap to build and maintain, and it has an almost immediate feedback loop. I mean, you can test thousands of business rules with unit tests in a few minutes. To get that same level of coverage from the UI would take literally hours, sometimes even days, just to execute. So I've also seen a lot of bad unit tests in my time, and I want to just offer a quick working definition of what I mean when I say unit tests. I have 4 basic rules and a fundamental principle that I use for classifying unit tests. So the 4 rules are, number 1, it never hits a database. It never hits the file system, number 2. Number 3, it never goes over the wire, whether that's TCP or HTTP or whatever protocol you're using. And it runs in milliseconds, because again, one of the things we're concerned about here is the speed of feedback. And the primary principle that I really try to emphasize at this layer is to test behavior and not implementation. And the easiest way to kind of keep that focus is to make sure you're testing through your public interface, that part of your code that's exposed to some other part of the world, and not ever trying to get in and test your internals. So if you want to dive more into this topic, I suggest this YouTube video, TDD, Where Did It All Go Wrong? And Test-Driven Development by Example by Kent Beck. Both of these are great resources for really helping to dive into this principle and provide good guidance on unit testing. So part of the problem that I see, though, is a lot of code bases simply aren't unit testable. When we get into it and we start looking at how the code was built, it wasn't built with testability in mind, and it's really hard to create that isolation that you need. And so I used to really tell teams, start with unit testing, but now I'm more often telling them, well, think about how you get to unit testing if you can't do that. And the way that I like to encourage teams to do that is to move up one layer into that interacting subsystems and services, and to start wrapping certain areas of your application in tests to provide a safety net so that you can then move down into the lower area and do some refactoring and make it more testable. And there's really no one-size-fits-all approach here. There's not a single tool that's going to solve all your testing problems at this layer. There's a lot of complexity involved. Often you're going to need some sort of custom framework to address the challenges of your architecture. And so my approach is to start looking at the architecture and figuring out where are there seams in the system where logical blocks of application processing that can be isolated and validated apart from the rest of the system. Maybe it's a service layer within an application code base where I can validate several classes and modules together. That's represented here on this diagram as the component tests. Maybe it's a RESTful or SOAP API where tools like Postman or REST Assured or SOAP UI or Karate can help you exercise those public-facing APIs. And at these types of tests should really be focused on the contract that your APIs have with the world, and making sure that as you're making changes to your API, that you're not breaking those contracts that you've published and made available for external consumers. Maybe there's a collection of services that work together to process a collection of data. You might need some sort of custom tool that can send messages to a socket or a message queue, some sort of mock service on the back end of that set of processing that you can capture the output for verification. But ultimately, what you're looking for is somewhere a place where you have clearly defined boundaries, where you can control your inputs and capture and validate your outputs. And so at this layer, it provides us a way to begin to wrap certain areas of our application in behavior-focused tests, providing us that safety net so that we can go in and start refactoring and pushing tests down into the unit layer. So I realize I'm covering a lot of things and moving really fast. So again, if you have questions, please put them in the chat, and I'll try to address as many of those questions as I can at the end of our time today. So finally, we move to the top at the UI layer. And this is what a lot of people tend to think about when you talk about automated testing, is testing through the UI. And I had a whole section in here originally talking about what I hear is the common goal of test automation at the UI layer and how it's the wrong goal. But I think it's sufficient to just say you can't automate everything at the UI layer. It's too expensive, it's too costly to maintain. The feedback loop is too slow. So just don't even try. It's you need to be thinking critically about what you really want to test at this layer. And so there's a couple of questions I like to ask around what should we be testing at the UI layer? And the first question I ask is, well, can you validate what you want to test at any other layer than through the UI? If so, then do it. Most of what happens at the UI layer is just the presentation of data after it has passed through a number of layers of business logic. The business logic itself is inconsequential to how that data is displayed. So if you're trying to validate business logic, get as close to that code as you can with your test. Push it down the stack to the point where the behavior you're trying to validate is first fully expressed. Now, there are things that live in the UI layer, though, that can only be validated in the UI. Form field validation is kind of a simple thing that comes to mind. Although with a lot of modern frameworks like Angular and React, presentation logic actually can be tested in unit integration layer module tests. But things like form field validation, elements that should reflect localization, things like that are candidates for UI layer automation. But really what I like to focus on here goes back to what's called the Pareto principle, or also known as the 80-20 rule. And this states that for many events, roughly 80% of the effects come from 20% of the causes. So if you focus on 20% of the most used and most important features in your application, you're going to cover 80% of the critical paths of your application. And that doesn't mean you ignore the other 80% of the features, but you need to understand how your system is being used and what are the most critical and value-laden aspects of the system. And you build your UI test to exercise those features through that happy path. You need to understand how people are using your software. What are the business critical flows that the majority of people take to your software on a daily basis? I mean, really what we're talking about is risk. Understand where your risk is and automate to protect around that risk. Or to put it in the words of my esteemed colleague, Claudia Lasula, who recently blogged on this topic, what is the single most important feature of this product? Think of the feature that, if broken, will either cause the business to lose money or not make money. What is that feature or area of the system that when you tell developers they need to make changes to it, they feel like running away? Because that represents an area of risk. Everybody knows this area is fragile. And those are the two things that you really want to focus on when you start trying to define what you want to test at the UI level. Now, once you've kind of figured out what you want to test, the question becomes, how do you go about it? And there's a few fundamentals that I want to share with you. And this is just the tip of the iceberg. I mean, these are just kind of big picture things that I think are really important to think about. The first of which is ditch your record and playback tools. And I really can't stress this enough. There are several reasons for this. Record and playback tools are often marketed as a way to get up and running fast with test automation. And they have slick demos where some guy gets up and shows you how easy it is to create a test by turning on the recorder, running through the steps. And then he says, okay, now let's play this back. And he shows you how easy it is to replay the test. And it's cool to watch. I actually was not fired or laid off in a series of layoffs one time just because the boss was so impressed with how a test looked when it was running through the UI automation tool. But there's a really dark side to record and playback tools, and that's maintenance. Record and playback is fine if the application you're testing is never going to change. But then my question is, why do you need expensive automated testing if it's never going to change? So one of the key outcomes that you're concerned about is how your test automation is impacting your time to market. And with record and playback, you're going to get a real spike in the beginning, maybe, but it's not going to be long before the maintenance of those tests starts to take longer than just the manual execution of them did in the first place. And the other key motivation for record and playback or codeless tools is often because there's a lot of really talented QA people out there that don't have any coding skills, and they're being told, learn to automate or else. And this is a way for them to kind of start automating without knowing how to code. But here's the thing, codeless is a misnomer. Test automation is coding. That record and playback tool, it's generating code. It's code that has to be maintained. So I'm going to sidetrack for a minute, and I'm going to say something that's not often very popular, but it's really important if you want to build a successful automation program. And there's actually a lot of data to back it up. In the book, Accelerate, the Science of Lean Software and DevOps, the authors discovered in their research that one key characteristic of high-performing teams was that developers primarily create and maintain acceptance tests, and they can easily reproduce and fix them on their development workstations. It's interesting to note that having automated tests primarily created and maintained either by QA or an outsourced party is not correlated with IT performance. The theory behind this is that when developers are involved in creating and maintaining acceptance tests, there are two important effects. First, the code becomes more testable when developers write tests. And this is one of the main reasons why test-driven development is an important practice. It forces developers to create more testable designs. And second, when developers are responsible for automated tests, they care more about them and will invest more effort into maintaining and fixing them. Now, I want to make clear what this does not mean. This does not mean you don't need manual testers or testing. It doesn't mean you don't need QA professionals who are really good at understanding what needs to be tested and how. And I've heard this finding used as reasoning to dispense with the QA department and just have devs do all the testing. And I will tell you that that's a guaranteed surefire way to fail at quality. That's not what this means. What it means is that you have to break down the barrier, the wall between devs and QA, and cultivate a partnership where QA can inform your automated testing and development can enable your automated testing. But developers need to take an active role in building and maintaining these automation frameworks. And that pairing between dev and QA is also a way for those really talented QA analysts to start developing the skills needed to take over that automation in the long term. So the second fundamental that I want to talk about is taking control of your element locators. And this kind of goes along with getting rid of the record and playback tools. So every UI testing tool, whether it's mobile app, web app, or a desktop app, has to have some way of referencing elements on that screen that a user interacts with. And we call these element locators or selectors. And for example, on a web page, we may have something like this. This is a collection of radio buttons for making a selection. And if you want to reference this particular radio button label highlighted in yellow here from the test tool, you have to use a CSS selector or an XPath selector. If you're really desperate, you can actually use pixel compares using an element from a stored screenshot. I don't recommend that approach because it's really slow and hard to maintain. But recording tools are spy tools that are used to capture elements using some sort of computer algorithm or a simple AI. Just aren't smart enough yet to do that in a maintainable way. So this example here, this is a collection of selectors generated by one of the more popular codeless tools today when I used it to capture this element. And part of the problem with these kinds of auto-generated selectors is that they're highly susceptible to break when the page layout changes for any reason. This particular selector has 6 potential points of failure. If you have some experience with selectors, you might look at the first part and say, oh, good, we have an ID. I mean, IDs should be unique on a page, so that's a good start. And in fact, you often hear advice about making sure the elements have an ID or a name attribute, and that's fine. I use those if they exist. They're generally more stable than other aspects of the code hierarchy, but they still belong to the domain of the developer, and they might have a need to change them at some point. But if they exist, I'll use it. Except in this case, this happens to be an Angular material library element. And that number 7 is auto-generated by the library, and you can't be guaranteed to have the same number there every time, which essentially makes that ID unusable. And other problems here are everywhere that you see a single / represents an immediate hierarchical relationship that has to be maintained for the selector to remain valid. Introducing one or more wrapping div or putting that label inside a span, and now this selector is broken. And the indexes are the same way. The index select, the number 2 div and the number 2 span. That relationship is not only a direct relationship, but it has to be, you can't introduce any more siblings above that element or you're going to break the selector. So there are at least 2 different ways to make this selector better. So remember we talked about testability and the idea of breaking down the wall between QA and dev and having devs involved in writing the test. Well, one simple thing you can do as a dev is to add custom attributes to your HTML to make it more testable. So you could just simply come into this HTML and add this attribute, active, data-automation, and give it a value that makes sense. And now we can use that in our selector to target that element. And this is the ideal approach in my mind because it's completely unambiguous both to the test tool and to the humans that work on the code. A developer understands this attribute belongs to the domain of test automation. It has 0 bearing on what he or she needs to do with the code, from a development standpoint. So they should not, under any circumstance, have any reason or need to change this. Now, sometimes we don't have the luxury of getting those custom attributes. We're stuck with the HTML that we have. So we can go in and do some things and add a little intelligence to our selectors to make them a little bit more resilient. So here I'm still relying upon indexes, which is not ideal, but I've done so with some thought and intelligence because I know on this page and the way it's organized that this radio button group will always be first on the page because of what it represents from a business perspective relative to the other radio groups on the page. And second, I've done away with the intermediate relationships and I'm using relative relationships by using the double slash. So this locator reads, give me the first radio group on the page, and inside of that, give me the first radio button, and inside of that, give me the second span, which is the label I want. Now, there's a lot of things that can change on this page without breaking my selector. You can add additional divs, headers, or anything other than another radio button or span in this mix. And as long as those relative relationships of the elements stay the same, the selector will remain valid. So if you really want to become a great test automation engineer, you want to build resilient automation frameworks, you really need to become a master at writing effective CSS and XPath selectors. I can usually build a solid, stable selector usually in about the same amount of time as it would take me to fire up an automation recording tool or a spy tool and to capture it programmatically. And the advantage of mine is that because I put some intelligence behind it, I'm confident it's going to endure for time. So get your developers involved, take ownership, take control of your selectors, and learn how to leverage layers of abstraction. In computer, an abstraction layer is a way of hiding complexity and expressing or exposing intentionality. You know, when it comes to flying an airplane, there's an enormous amount of complexity involved in getting it off the ground and keeping it there until you're ready to come down. But pilots don't think in terms of actuators, pistons, hydraulics, and electrical gates. So the complexity is hidden, and the intentionality, the goal behind all those systems, is expressed in a ubiquitous and domain-specific language that the pilots understand. And all cockpits generally share the same language, more or less. And we do this in test automation by using layers of abstraction. At the top layer, we have the actual test that describes what it is that we're testing. And this should be really business-facing language. And it should be a domain-specific language that expresses the concepts that are important in my domain. So I have an example here on the right. Given an account with $20 credit, when the shopper purchases $30 in merchandise, then the total before tax and shipping should be $10. We have a clearly expressed precondition. That's your data setup. We have the behavior we want to test, and we have the expected outcome. And I've used the common BDD approach of given, when, then here, but you don't have to do that. As long as your test language adequately captures that common data model and system behaviors that are important to your domain, then that's going to be valuable. Then we tend to encapsulate those things in business objects, reusable steps, building blocks, reusable workflows, common things that we do over and over again. We encapsulate those steps and those flows in reusable components that we can then use directly in our test. But the most common type of abstraction in test automation is the page object model. And this is, in simple terms, a way of modeling your application that makes sense from a business-facing perspective. What are the main pages of your application? What are the common shared elements of those pages, like your header and footer or menus? What about dynamic elements like repeating rows of data? We take all of these things, we break them down into reusable components, and then we build page models using composition to represent the major pages or views of the application. And this is the first time we really actually start to see the test tool APIs being expressed. None of that API for those test tools should bleed into the test itself. Those need to be encapsulated and pushed down into the lower layers of the framework. So for example, here's a couple of tests that were captured using a recording tool. And so the first thing you'll notice is you have actual driver, WebDriver API calls directly in the test. Find element, by CSS selector, the click, the send keys, all of these things that are part of the WebDriver API. You should also notice that in these two tests, they cover the same ground. And so you have a lot of duplication here in those first 4 lines of code. They're exactly the same in both tests. And if you think about a login scenario where every test that you do has to go through a login page, and if you use record and playback tools and you capture that login every time, if a developer changes something on the login page that breaks one of your element locators, you find yourself having to edit 100% of the tests that you've recorded in order to fix that element locator. And that's part of that maintenance problem that I talked about. So if we can take this information and we can encapsulate it inside a page model, and so here's the login page model. I have my username field, my password field, my login button, and then I have a business flow or a step called login with that allows me to supply a particular username and password, and it's able to pass that on to the form fields and click the button. And then I can take that and integrate it back into my test. So now I have three page models: my welcome page, my login page, and my secure area page. And I can ask my welcome page to navigate to the login form. That's that domain specific language. And I can ask the login page to log in with Tom Smith and my super secret password. And the test is pretty clear what's going on. I don't have a lot of the complexity of the API getting in the way of the intent of my test. And then my tests themselves can be focused on what it is they're actually validating. In the first case, I'm validating that the message text in the secure area page is what I expect it to be. And in the second case, I'm validating the header text. So I've talked about these few fundamentals: development involvement, taking control of your selectors, and leveraging abstractions as just some key things that I've learned over the years to help make test automation at the UI level more successful. Now, I just realized I skipped over a major component of this, and I'm running short on time, but I don't want to not talk about it. So let me just jump in here real quick and talk about production data. We talked about introducing data. And one of the things you have to do in test automation is to make sure you provide a way for the person writing the test to easily describe and define test data and introduce it into the system. So here's an example of a data builder that we supplied for this test setup. And it expresses very clearly what the test needs in terms of the data setup. Given an active park, given a product for that park, and an account that has a subscription for that product at that park. As you start writing tests, you should be thinking about what the data in the system looks like. Model your domain, understand what characteristics affect behavior, and then canonize those things in a domain-specific language that can be used to communicate clearly the intent of the test. There's a lot of complexity here, but that's okay, because we have that encapsulated in a domain-specific language that provides a way to configure with a great deal of flexibility and data what you need for any given test. So one of the cool things about data builders is that it begins to cultivate a language that allows you to talk about what's important in your system. Martin Fowler put it this way. He said, canned objects that the object mother or data builder produces becomes familiar to the team, often invading even discussions with users. In this way, they resemble the notion of personas, although they aren't always people. And it's probably obvious that there's a lot of work that goes into this, but consider the payoff. If you build these data builders in a way that can be shared across your enterprise, it can be leveraged by every developer, automation engineer, to quickly set up and tear down test data for their tests. Even manual testers can be empowered with these tools to quickly articulate and create data that's needed for manual and exploratory testing. Data builders are really important because they help you understand what the data in your system, what is important in your system as far as data. And they help you to express that domain-specific language that facilitates that conversation between business, PM, and development organizations. So what is your test strategy? Is your code testable? Have you thought about how to manage test data? These are all questions that you need to consider before you just jump in and start building automation with the newest codeless or low-code test tool that's out there. Because if you don't think about these things, if you don't come up with a strategy, you're going to end up with a bunch of tests that pretty quickly are going to become an albatross around the neck of your productivity. All right, I've covered a huge amount of ground today. I feel like I've talked really fast. I know there has to be questions out there. So let me stop here and check in with Jen, and let's see what questions we have.
Yeah, hey Alan, yeah, you do have some questions, and I will put those links into the chat window. But yeah, sure, let me tee up the questions for you.
Great, thank you.
Sure. All right.
While she's getting those, I've put up a list of the resources that I've used to build this presentation. And I think Jen can provide these links in the chat for you so that you'll have quick access to them. But if you want to take a screenshot of this, or it's also be available recorded once we get that published to our YouTube channel.
So here are the questions that were asked by your attendees today, Alan. The first question is, hitting an in-memory database acceptable for unit tests?
So as with all rules, sometimes rules are meant to be broken. I say it's my general rule for writing tests. There are times when in-memory becomes valuable and useful. And there are times when hitting a real database could be done. The thing you want to keep in mind is that unit testing is about speed of feedback and low overhead when it comes to setting up and tearing down. So if you're,
Alan.
I'm sorry?
Oh, sorry. Something was repeating. I got bad network quality for some reason. I don't know why.
That's fine.
Apologize.
If you're building unit tests and you find yourself spending a huge amount of time constructing or managing data, you're probably in that integration layer, in that next layer up. And you really have to think about your data strategy at that point and how you're going to manage that test data. So the answer is, yeah, it's probably acceptable at times, but make sure that you're not slowing your speed of feedback down. And the other thing that I have for unit testing is somebody should be able to download that code base and run the test without any local configuration and setup. If you can't do that, now you're in the realm of integration testing, and you should really think about how you're managing that. But at the end of the day, that's just kind of semantics of what you call your test. You are going to have tests that need to interact with the database. So the next question I see up here is, given the cost of automation and how much effort it takes to build a successful automation program, is it really worth it? What's the return on investment? Yeah, I mean, that's a good question. It is costly to build automation, but you have to think about the long-term cost of testing. When your application is small, manual testing can be done pretty effectively, pretty quickly. But as your application grows, the amount of time it takes to do that regression cycle grows exponentially. And you just can't, there comes a point where you can't get it done fast enough, and testing becomes that real bottleneck to getting to production quickly. When you get into the world of DevOps and Agile, where you're trying to deliver weekly or even daily into your production environment, you just can't do it unless you're doing effective test automation. And so that cost, that return on investment, is not just about being able to test faster, but it's actually being able to get things into production faster so that you get feedback from your users faster as well. So it's definitely worth the investment. And here's another question. What place does manual testing have in this model? Seems like a good automation strategy could remove the need for manual testing. Yeah, so when I first started using the test pyramid model to talk about this strategy, my modification to that model, like everybody has a little modification, was I drew a little circular cloud at the top that said exploratory testing. Manual testing is like, so automated testing is like walking through a minefield where you've cleared a path to that minefield, and you're just checking that that path doesn't have mines being reintroduced into it. And there's a lot of value there, but it doesn't discover those mines that are a little bit to the right or a little bit to the left. And they don't discover defects that are sometimes only caught because a human mind sees something that looks a little bit unusual. And so what automation does is it frees up time for more effective exploratory manual testing. And I think it's really important to keep that as a key part of your strategy, your overall quality strategy, that you have human beings interacting with your application, applying that human creative thinking and intelligence to the testing. And the automation is a tool that enables that and that empowers that by freeing up time. Manual testers, if they're just going through scripts, repeating steps, they're going to miss things. But if you can do that with your automation and give them the ability to think creatively about what they're looking at, you're going to get a lot more value out of that manual testing. And the final question I see up here is, how can automation keep pace with new development, and how do you get all your regression suites automated when you're pushing out a branch of new functionality? So this is always a challenge and a struggle. And there's a couple of approaches here. There's one approach that one of my colleagues likes to call the Big Bang approach, where you throw a lot of resources at a regression suite for a short amount of time to trying to get over the hump of providing a foundational set of regression tests that you can then use going forward. And that's kind of a one-time Big Bang event where you just kind of throw all the resources at it for, 3 months, 4 months, 5 months, whatever it takes. And then you change your focus from that point to new development. That's obviously an expensive endeavor and is not always feasible. And so what I tell people is, what is actually changing in your application? And focus on your automation there, and build your automation process so that you are writing tests first as part of your story grooming, as part of your backlog planning. Get into a process where you can define the tests that you want up front, and then your automators can start working on the automation for that while the developers are writing the new code. And I recommend a book called Specification by Example if you want to kind of dig into that process and how that can actually work on your Agile teams. Are there any more questions that came in, Jen?
No, Alan, those are the questions that we have. I will put into the chat window all the links that you shared earlier in the presentation.
Great.
Is there anything else that you'd like to mention before you wrap up your Lunch and Learn today?
I just, thank you all for taking your time out and joining me. I hope this was helpful to you. Please take a look at the Improving website for other Lunch and Learn events. Jen, maybe you can post the link to those events so that people have a way to get to those.
Actually, you just had a question come in. It says, any thoughts on mocking, and what are your favorite tools?
So mocking is a two-edged sword. I used to be a really strong proponent of mocking, but as I've gained more experience, mocking can lead to too much of a coupling of your unit testing to implementation details of your code. So I made a very quick comment earlier. My fundamental principle was focus on behavior and not implementation. Mocking tools are really useful in terms of helping you to create isolation around areas of your code for unit testing and certain types of component integration testing. But you have to be really careful because they can also tie you to your implementation. So if you're using mocking for stub purposes, just to kind of help create isolation from those external services that you rely upon, that's fine. But if you're testing things like, hey, I'm expecting this call to be made with these parameters, and then I'm expecting this response back, now you're tying your test implementation, and you're going to find yourself in a maintenance problem pretty quickly as you have a need to refactor and change the implementation of your underlying code. So that's a great question. And this Ian Cooper in his TDD, Where Did It All Go Wrong, really spends a lot of time talking about that very specific problem. Great question.
Excellent. Well, that is all the questions that have come in today, Alan. I have sent out the links, the helpful links in the chat windows. I did try to separate them, and so maybe we can send out in a separate email to all the attendees, Alan, the helpful links and any portions of your presentations that you might be interested in.
Absolutely. And feel free to reach out to me on LinkedIn or on my email. Oh, wrong one.
Can you share that? Can you share that again, Alan?
Yep.
That part of your screen, that way I can have that present.
There it is. Can you see it?
Yep, that is perfect. Thank you.
Just if you do reach out to me on LinkedIn, just mention this presentation so that I know, I have some context for how you know me. And again, thank you, everyone, and have a great day.
And attendees, thank you so much for joining us today. This event, this Lunch and Learn, was recorded, and it will be posted on the Improving YouTube website. And if you have any questions, you know how to get in touch with Alan. When we thank you for your time.